Welcome back. Hey guys, it's Rishi once again, and we're back with our final video of our Part 1 Python programming course, and this is where we'll be testing our code. So when you write a function or a class, you can also write tests for that code. And so what does testing prove, and what do we do here? So testing proves that your code works as it's supposed to in response to all the input types that it's designed to receive. So when you write tests, you can be confident that your code will work correctly as more people begin to use your programs. So in this chapter, what are we going to learn? Well, you'll learn how to test your code using tools in Python's unittest module. You'll learn to build a test case and check that a set of inputs results in the output that you want. And you'll see what a passing test looks like and what a failing test looks like. And then learning how a failing test can help you improve your code before finally learning how to test functions and classes so you can start to understand how many tests you need to write for a project. So with all that said and done, let's dive into this right away. So the first thing we're going to be covering is testing a function. To learn about testing, we need code to test. And here's a simple function that takes in a first and last name, and then we're going to return a neatly formatted full name. So let's start with our definition, and we're going to go for get formatted underscore name. For those who watched our previous set of videos, in fact, I think chapter 8, which was around functions, we are following through with the first program we worked from there. So we've got our function get formatted name, which is going to take two parameters, first and last. We're then going to put in our doc string, which is to generate a neatly formatted name before writing out our full underscore name, which equals our first name plus our last name, before returning our full name dot title. Marvelous. So the function get formatted name is now combining the first and last name with a space in between to complete a full name, and then capitalize it when returning it. So to check that this works, let's make a program that uses this function. So we're going to create a file called names.py within this section here. And within this program, we're going to let the user enter in a first and last name and then see a neatly formatted full name. So we'll go from testing, import our get formatted name. So what have I done? I found the file name, which is testing, and then I want to import my get formatted name. Let's go ahead and put in a print statement to say enter Q at any time to quit. And then we'll start off with our while loop by saying while true. Let's put in our first input. We'll go for our new line and say, please give me a first name. And then we'll say if the first equals Q, so if the user enters in the letter Q, then we want it to break. Otherwise, we'll put in our last and say, please give me a last name. And then again, if last equals the letter Q, then we are also going to break. Before finally getting our formatted name, so we've got get formatted name, we've assigned it to a new variable with both our first and our last names here. And let's go ahead and print this out. So this program imports the get formatted name function from our testing.py. And so the user can enter in a series of first and last names and then see the formatted full name that is generated. So let's go ahead and run this and see what we get. Alrighty, so please give me a first name. So let's go for Rishi. And please give me a last name, Bagger. Okay, neatly formatted name, Rishi Bagger. And again, as this is a while loop, this is going to continue. Let's go for Bob. Let's go for Dylan. You can see Bob Dylan. Let's go again. Let's go for Q, and it should break. There we are. So now we can see that the names generated here are correct. But let's say we want to modify this function here so it can also handle middle names. Now, as we do so, we want to make sure we don't break the way the function handles names that only have a first and last name. So we could actually test our code by running testing.py and entering a name like Rishi Bagger every time that we modify this getFormatted function. But that would become tedious. So fortunately, Python provides an efficient way to automate the testing of a function's output. So if we automate the testing of getFormattedName, then we can always be confident that the function will work when given the kind of names we've written tests for. So let's now go back to our testing here, and let's talk about unit tests and test cases. So the module unit test here, this is from the Python standard library, and it provides tools for testing your code. So now a unit test here simply verifies that one specific aspect of a function's behavior is correct. And so a test case is simply a collection of unit tests that together prove that a function behaves as it's supposed to within the full range of situations that you expect it to handle. So a good test case would consider all of the possible kinds of input that a function could receive and includes tests to represent each of these situations. A test case with full coverage includes a full range of unit tests covering all the possible ways that you can use a function. And it's often good enough to write tests for your code's critical behaviors and then aim for full coverage only if the project starts to see widespread use. So let's take a look now at our parsing test. So now the syntax for setting up a test case takes some getting used to, but once you've set up the test case, it's straightforward to add more unit tests for your functions. So in order to write a test case for a function, the first thing we need to do is import the unit test module and the functions that you want to test. So again, we'll go from testing, import getFormattedName. And again, I'm doing this in testing, so it's not really going to work. So I'm going to take this out and I'm going to create a new file here. And I'm going to call this testing_name.py and paste it in there. So again, what have we done? We've imported our unit test and we said from testing, import our getFormattedName function. Then we need to simply create our class that inherits from the unit test.test case. So let's go for names test case. This is all in our camel case. And then we'll have our unit test.test case. We'll then go ahead and put in our doc string, which is again tests for the testing.py, before finally going ahead and writing out a series of methods to test the different aspects of your function's behavior. So again, I'm going to start off with definition test underscore first underscore last name. I'm going to take self as my method here, and then go ahead and put in a doc string. And let's say, do names like Rishi Bagger work? So again, we'll put in our definition test. Let's go for our first and last name. So then within this, let's go for formatted name. Let's go for get_formattedName. And let's put in two arguments. Let's go for Rishi as the first and Bagger as the second. And then we're going to go for our self.assert equals. And within this, we're going to have our formatted name. And we'll write out Rishi Bagger. Wonderful. So let's go through this in detail. So first, I've gone ahead and imported the unit test and the function that I want to test, which is our getFormattedName. We then go ahead and create a class called namesTestCase, which will contain a series of unit tests for getFormattedName. And you can name the class anything that you want, but it's best to call it something related to the function that you're about to test, and to use the word test in the class name. And this class must inherit the class unittest.testCase, so Python knows how to run the tests that you write. And so namesTestCase contains a single method that tests one aspect of getFormattedName. And we call this method the test first last name, which is my definition here. And that's because we're verifying the names with only a first and last name to ensure that they are formatted correctly. So any method that starts with test will be run automatically when we run the testing function. So within the test method, we call the function that we want to test and store a return value that we're interested in testing. So in this example, we call the getFormattedName here with the arguments Rishi and Bagger and store the result in formatted_name. So then the third position here, we use one of the unit test's most useful features, which is an assert method. Now, assert methods verify that a result that you received matches the result that you're expected to receive. So in this case, because we know get_formatted_name is supposed to return a capitalized, properly spaced full name, we expect that value in formatted name to be Rishi Bagger with a capital letter. So I'll go ahead and drop this to a lowercase. So to check if this is true, we use the unit tests method and pass it formatted names such as Rishi Bagger to see if it's true. So now we've gone ahead and done that. Let's go ahead and explain this in a little bit more detail. So this line simply says, compare the value in formatted line to the string Rishi Bagger. If they are equal as expected, then that's fine. But if they don't match, let me know. So now we've done that, let's go ahead and write out a final line here, which is going to be unittest.main, and we're going to call that line. So now in line 13, unittest.main simply tells Python to run the tests in this file. So when we run testing.py, we should get a following output, which is run the test in how many seconds. And if it's okay, it should say okay. So let's go ahead and print this out. And there we are. You can see it's run one test in 0 seconds and everything is okay. So now the dot on the first line of the output tells us that a single test has passed. The next line tells us that Python ran one test and it took less than 0.001 seconds to run. And then the final OK tells us that all unit tests in the test case have passed. So this output indicates that the function getFormattedName will always work for names that have a first and a last name unless we modify the function. So when we modify getFormattedName, we can run this test again. And if the test case passes, we know the function will still work for names like Rishi Bagger. So I hope that was a clear introduction into a passing test and how we can work with unit tests and test cases. But let's now think about a failing test. And what does a failing test look like? Well, let's modify our getFormattedName so it can handle middle names. But we'll do so in a way that breaks the function for names with just a first name and a last name, like Rishi Bagger. So I've just written out my function, and this time I've got a middle argument included in that. So now I've written that out, I'm going to go ahead and cut this out, go back into my testing.py and paste this here. Let's go ahead and comment this out here. So now this is all being modified. Let's go ahead and run this and see what our output is. So let me go ahead and clear my terminal and let's run this. Okay, and there we are. What do we see here? Well, this time running the file gives us an error. And we can now see, we've got our question, does names like Rishi Bagger work? But we've got E. So now there's a lot of information here because there's a lot you might need to know when a test fails. So the first item in the output here is the single E, which tells us that one unit test in the test case has resulted in an error. Next, we see that first_last_name in the name test case has caused us an error. So knowing which test failed is critical when your test case contains many unit tests. And so this gives us our question, do names like Rishi Bagger work? And then we have a traceback error. And so within this traceback error, this reports that the function call getFormattedName Rishi Bagger no longer works because it's missing a required positional argument. And we also see now that the unit test was run, which is what you can see here, ran one test. And then finally, we can see an additional message which states failed errors equals 1. And this information appears at the end of the output, so you see it right away. And you don't want to scroll up through a long output listing to find out how many tests have failed. So what has happened? Well, we've gone ahead and we've added on an additional argument, which is required. And because we have not given one within Rishi Bagger, it's giving us an error. So how would we respond to a failed test? Well, assuming you're checking the right conditions, a passing test means the function is behaving correctly, and a failing test means that there's an error in the new code that you've written. So when a test fails, don't change the test. Instead, fix the code that's caused the error to fail. Examine the changes that you've just made to the function and figure out how those changes broke that desired behavior. So in this case, our getFormattedName used to require only two parameters, a first name and a last name. But now it requires a first, middle, and last name. So the addition of that mandatory middle name parameter broke that desired behavior. So the best option here is to make a middle name optional. Once we do, our test for names like Rishi Bagger should pass again, and we should also be able to accept middle names as well. So let's go ahead and modify this function so middle names are optional. And then if it passes, we'll move on to making sure that the function handles middle names properly. So let's go back into our testing.py here. And to make the middle names optional, we have to move the parameter middle to the end of the parameter list. And then we need to give it an empty default value. So at the end of middle, let's go for equal, and we give it an empty value here. And we also add an if statement that builds the full name properly, depending on whether or not the middle name is provided. So let's go over here and let's say if middle, then we'll have our full name, which equals first, middle, and last. Else, we'll just have our full name, and I'll just go ahead and copy out this code here, which is above, and paste it down here. And then again, we can go ahead and return our full name.title. So now, in this new version of getFormattedName, the middle name is optional. If a middle name is passed to the function, which is if middle in our line 15, then the full name will contain the first, middle, and last name. Otherwise, the full name will just consist of a first and a last name. So now the function should work for both kinds of names. So to find out if this works, let's go ahead and run it. And there we are. We've now got test, ran test 1, and it's all okay. So the test case passes now. And this is ideal because it means the function works for names like Rishi Bagger again without us having to test the function manually. And fixing our functions was easy because the failed test helped us to identify the new code that broke existing behavior. So now the next thing I want to dive into was adding new tests. So I hope you've had a clear introduction into how test cases are working, whether they pass or if they fail. But now let's move over to adding new tests. So now that we know getFormattedName works for simple names again, let's write a second test for people who include a middle name. And we're going to do this by adding another method to the class namesTestCases. I'm just going to move this section to our testing.py, and let's go ahead and add our new tests. So now that we know getFormattedName works for simple names again, let's write a second test for people who include a middle name. And so we're going to go ahead and do this by adding another method to our class namesTestCase. So let's go ahead and write out our function here, and let's go for test underscore first underscore last middle name. And again, we'll take self as one of our methods here, and we'll put in our doc string. So do names like Rishi Junior Bagger work? So that's our doc string there done. So let's go with formatted underscore name, and we'll assign this to our getFormattedName here. I'm going to go ahead and open my brackets, and let's give it 3 arguments. So let's go for Rishi, let's go for Junior, and let's go for Bagger. Now we've gone ahead and done that, let's call our self.assert equal method. We'll call our formatted name, followed by our Rishi Junior Bagger. Wonderful. So now, what have we done? We've gone ahead and we've named this new method test first, last, middle name. And the method name must start with our test. So the method runs automatically when we test our name function. So we named the method to make it clear which behavior of getFormattedName we're testing. And now as a result, if the test fails, we know right away what kind of names are affected. And it's fine to have long method names in your test case classes. And they need to be descriptive as well, so you can make sense of the output when your test fails. And because Python calls them automatically, you'll never have to write code that calls these methods. So now, to test the function, we're going to get a formatted name here with a first, last, and middle name. And then we use our assert equal to check the returned full name matches the full name that was given. So when we run test name function, let's take a look if both tests pass. And there we are. You can see over here that it's got ran 2 tests. But hey, we've now got failed. And it states here that Rishi Bagger Jr. does not equal to Rishi Jr. Bagger. So why could that be? Could it be because of the order? Or could it be because of the capital letter and the lowercase? Well, let's have a look. Well, I'm now going to change this to Junior, as this is our middle name, and keep this as Rishi Bagger. And I'll do the same to this one here. Let's change this to Bagger. Let's change this to Junior. So let's now go ahead and clear my terminal and run this. Oh, we're still getting a failure here. And you can now see it's pinpointing this to our lowercase and uppercase. So I've gone ahead and changed the order, but now it's talking about the lowercase and uppercase. So let's change that. So let's now go over here and let's make this a capital J. Let's clear my terminal and let's run this. And there we are. We've now got run 2 tests and everything is okay. So I hope you can see that the order, as well as whether it's a capital letter or a lowercase letter, matters the most. So now we've tested this, great. We now know that the function still works for names like Rishi Bagger, and we can be confident that it will work for names like Rishi Junior Bagger as well. So that brings me to the end of our first section. I've now got 2 programs that I would like you to attempt. So feel free, just like we've done in our previous videos, feel free to pause the video, attempt the question before pressing play and going through the solutions with myself. You've done amazing work, and I hope you can see the value here of testing your work, responding to failing tests and how to rectify the issues. Keep up the great work. Welcome back. Okay, let's go ahead and dive into our chapter 10 solutions here. Let's go ahead and open that up. And we've got through programs that you went through. So let's go ahead and start off with the first one. Well, it's now asking you to write a function that accepts 2 parameters. And within these 2 parameters, it's going to be a city name and a country name. The function should return a single string, such as Santiago, Chile. And then we want to store that in our city.functions.py file. But I'm going to go ahead and store it within my chapter 10 solutions. I'm then going to go ahead and create a new file called test cities, and that's just simply going to test my function that I've written. And again, we need to go through the same step of importing our unit test and testing that out. So let's go ahead and write out our docstring, and that's just simply going to be a collection of functions for working with cities. And then let's go ahead and write out our function here. So let's start with defining our city_country, 2 parameters, which is going to be city and country. We then can go ahead and write out our docstring, which is simply returning a string like Santiago and Chile. So that's all in all done. Before going ahead and returning our statement here, and let's go for city.title and our country.title. Marvelous. So now remember here that this was the function that we had written in exercise 8.6, so in our functions program. So now I'm going to go ahead and I'm going to create a new file and call this test_cities.py. And I'm going to put 10 in front of it, just so we know that it relates to chapter 10. And let's go ahead and import our unit test from chapter 10 solutions.py, import our city_country. We'll take away .py here. We'll then create a class, cities test case. Remember to always put that in your name. We'll take our unit test.test case. Beautiful. We'll then put in our docstring and we'll put in a function. So we're going to define our test_city_country, which is going to take one method, which is our self method. We'll then go ahead and put in our docstring for this section here, which is, does a simple city and country pair work, before simply declaring a new variable, which is going to be Santiago_Chile equals our city_country, and we're going to put in our arguments. So Santiago, and Chile. Fantastic. We'll then call our self.assert equal method here, where we'll go for our Santiago, Chile, and we'll put in our arguments. Fantastic. And then in order to run it, let's go ahead and write out our ifName method here and assign this to our main. And then let's call our unit test.main. Marvelous. Okay, let's go ahead and run this. Let's go ahead and clear our terminal before running this. And there we are. We can now see we've run one test and it's given us a pass here. Okay, let's now move over into our second program here, which is population. So this is where we need to modify our function. So it requires a third parameter, which is population. So now it should also return a single string of the form city, country, and population. And it's also giving you an example here. We need to also make sure that it fails this time before going ahead, modifying it so the population parameter is optional, and then writing a second test, which verifies that we can call that function with the same values. So let's go ahead and modify this. So I'm going to go in here now and just underneath my document string, output string, and then let's remove our return and put this line equal to this variable output string. I've now gone ahead and done that. Let's go and declare output string again. And now we're going to increment a multi-line statement here. And so let's go with our population. And again, this is being highlighted because we haven't added it on as a optional before simply returning our output string. Wonderful. So we've modified this with the required population parameter. We can now go ahead and print this out. So let's go back into our test cities here, save this and run this. And what do we see? We've got an error. It's failed. So that's your first part done. We've got our traceback error saying it's missing one required positional argument. It's ran one test and it's failed. But now let's go ahead and modify this. So this time in our second test that this passes. So let's jump back here. So I'm just going to copy this, paste this here so we know this one will fail. And let's make changes to our first program. So we've now got population. We're going to make this equal to 0. We've got our return statement here, but this time I'm going to make a little change and return a string representing a city country pair. I've got my output string in place where it's got my city and my country. And then I'm just going to put in an if statement here. So I'm going to write if population has the output string, then return the output string. Wonderful. So now let's go ahead and go back to our file here and let's run this. And there we are. We've run one test and it's all okay. Amazing. So now that that is all done, we're going to move over to our final part. And this is where we need to verify that we can call our function with the values of Santiago and Chile as well as our population. So back over to this, we've got our import statement. We're calling it from our chapter 10 solutions file. We're testing for our city functions. So let's now go ahead and declare a new method. And this is going to be test underscore city underscore country and population. Remember always to start off your method with the word test. We'll then go ahead and write out our docstring here. Don't forget to put your self method. And then let's go ahead and declare a new variable. And so let's go ahead and copy out line 10, but this time we are going to add on the information about the population. So let's go for population equals, and let's go for 500,000. Now we've gone ahead and done that. Let's go for our self.assert equal Santiago underscore Chile. And let's write out our Santiago, Chile, and our population as 500,000. Fantastic. Now that is all done, we should now get an output statement stating that we've run 2 tests and it should all be okay. And there we are. We've now run 2 tests and they're all okay. Beautiful. So I hope those 2 challenges were useful, and I hope you can now confidently work with functions, and I hope you can now work with importing unit tests and functions in order to test your programs. Wonderful. That was a short exercise. Let's now jump back into our testing file here, where we will continue and move on to testing a class. So in the first part of this chapter, you wrote tests for a single function, but now you'll write tests for a class, and you'll use classes in many of your own programs. So it's helpful to be able to prove that your classes work correctly. And if you have passing tests for a class that you're working on, you can be confident that improvements that you make to the class won't accidentally break its current behavior. And this is where we'll be touching on a variety of assert methods. So Python provides a number of assert methods in the unittest test case class. And as mentioned earlier, assert methods test whether a condition that you believe to be true at a specific point in your code is indeed true. And if the condition is true as expected, then your assumption about how that part of the program behaves is confirmed. And you can be confident that no error exists. And if the condition that you assume to be true is actually not true, then Python would raise an exception. So now I'm going to go through and showcase an image of a table which describes 6 commonly used assert methods. And with these methods, you can verify all of the different returned values, whether they're equal or not, as well as the accepted values. And remember now that you can use these methods only in a class that inherits from unittest.testCase. So let's look at how we can use one of these methods in the context of testing an actual class. So now, testing a class is similar to testing a function, and much of your work involves testing the behavior of the methods in the class. But there are a few differences. So let's write a class now to test. And let's consider an anonymous survey. Within this anonymous survey, let's write out a docstring that we're collecting anonymous answers. Now, within this, we're going to define our method, and we're going to store the questions and prepare to store our responses. So I've got my function written out here. And within this, let's go ahead and write self.question, and let's equal this to question before having our self.responses equal to an empty list where they will all be stored. So what have we done? The class has now started with a survey question that you provide and includes an empty list to store the responses. We'll then move over to writing another method where we're going to show the questions. Again, we'll take self as our method here. We'll then put in a docstring, which is going to be to show the survey questions before printing the questions. So now we've gone ahead and written that out. The class has methods to print that survey question. And we're now going to add a new response to the response list. So let's go for our def store responses. Let's take 2 arguments, self and new response. Let's put in let's go for store a single response to the survey. And then let's call self.responses and let's append a new response to that. But before simply going ahead and printing out all of the responses stored in the list. So let's print out our survey results. So for response in responses, let's print it out plus our response. Marvelous. And so let's go ahead and now select our language. And you can see now, as I'm typing in these languages, they're going to keep on looping until I press quit. And then you can see, thank you to everyone who participated in the survey, as well as our survey results. And so this class works for a very simple anonymous survey. But let's say we want to improve AnonymousSurvey and the module it's in, which is your testing.py. So we could allow each user to enter more than one response. And we could write a method to list only unique responses and to report how many times each response was given. However, implementing changes would risk affecting the current behavior of this class. For example, it's possible that while trying to allow each user to enter multiple responses, we could accidentally change how single responses are handled. So to ensure that we don't break existing behavior, we would need to develop further within this module and write tests for the class. So let's now go ahead and test for this. So let's go back into our testing here. And let's go for testing the AnonymousSurvey class. So within this, we're going to write a test that verifies one aspect of the way that this survey behaves. And we'll write a test to verify that a single response to the survey question is stored properly. And then finally, we'll use the insertIn method to verify that the response is in the list of responses after it's been stored. So again, I'm going to create a new file called test_survey. Just going to comment this out so we can refer to this if we need to in the future. So let's go to our testing here, create a new file. And in this, let's start off by importing our unit test. We'll then say from testing import our AnonymousSurvey. We'll get our class in place. We've got our unittest.testCase. And then we'll also put in our doc string and start off by testing this through the single response. We've got a test store single response. We'll take self as our parameter here before going ahead and putting our doc string followed by a question. What language did you first learn to speak? I'll then go ahead and declare a new variable, my_survey, and link that to AnonymousSurvey followed by question before finally calling my survey.store responses. And I'll set this as English. And then finally having myself.assert in method here, where we'll have English as our argument and my_survey.responses before finally calling my unit test.main. So let's go through this once more. So I've started off by importing the unit test here and the class that we want to test. And we call our test case test_anonymousSurvey, which again inherits from the unit test. And the first test method will simply verify that when we store a response to the survey question, the response ends up in the survey's list of responses. And a good descriptive name for this method is test store single response, which is what you can see here. And if this test fails, we'll know from the method name shown in the output of the failing test that there was a problem storing a single response to the survey. And so to test the behavior of a class, we need to make an instance. And so we create an instance called mySurvey with the question, what language did you first learn to speak? We then store a single response using the store response method before finally verifying that the response was stored correctly by asserting that English is in the list of my survey responses. So let's go ahead and clear my terminal and then run this. And so what do we see? We've run one test and it's all okay. And so this is good. But a survey is useful only if it generates more than one response. So now let's verify that 3 responses can be stored correctly. And so to do so, we're going to go ahead and add another method. So just beneath here, let's go ahead and add one more method. And this time it's going to be called test store 3 responses. Self parameter. And then again, let's put in our doc string followed by our question and our new variable, my survey. And this time I'm going to put in 3 responses here. So responses equals, let's go for English, let's go for Spanish, and let's go for French. And so now I need to print this out. So this is where we are going to bring in our for loop. So let's go for response in responses. So let's call my survey here dot store responses, and let's call our responses our argument. Fantastic. And so now that is all done, we can finally put in a for loop here, for response in responses. Beautiful. So let's take a deeper dive into this. So we call a new method here, test store 3 responses, and we create a survey object just like we did in the test score, single response, which is here. And we define a list containing 3 different responses, which is English, Spanish, and French. And now once the responses have been stored, we write another loop and assert that each response is now in my survey responses. So when we run this, both tests should now pass. And there we are. We've ran 2 tests and they're all okay. So this works perfectly. However, these tests are a little bit repetitive. So we'll now use another feature of unit test to make them more efficient. So again, as you can see, we've gone ahead and worked with 1 response, now with 3. But the next part is called the setup method. And that's where we are going to create a new instance of AnonymousSurvey in each test method. And we're going to create new responses in each of those methods. So let's go back to our testing here. And let's go for the setup method. So now the unittest.testCase class has a setup method that allows you to create these objects once and then use them in each of your test methods again. So when you include a setup method in a test case class, Python simply runs the setup method before running each method starting with test underscore. So any objects created in the test method are then available in each test method that you write. So let's now use the setup method here to create a survey instance and a set of responses that can be used in your test underscore store single response, as well as your test underscore store 3 responses. So back over to our test survey here. So now let's go ahead and make some changes. Just underneath our class here, I'm going to go ahead and write up a new method. And as you can see, that's your setup there done. Let's go for our setup method. And we'll take self as 1 parameter. And let's put our doc string in place and say create a survey and a set of responses. We'll then go ahead and take up our question here, as well as the 3 languages that we've written out. We'll then go ahead and paste out the same question that we had, followed through with self.mySurvey. And let's equal this to our anonymous. And we'll put question as our argument there. Before going to self.responses, and we'll equal these to English, Spanish, and French. We then take a look at our single response method here, and we can now take away our question, my survey method as well here. And we're going to replace this with our self.my_survey and then initialize this. And then we're going to replace this with our store response, so we can call the store response as well as our self response, as well as finally the assert method here. And now we've gone ahead and done that, we can make a few changes to our final method, which is our 3 responses here. So again, removing this section and then replacing it with what we already had here. Beautiful. So now the method setup does 2 things here. It creates a survey instance, which is what we've done here. And it creates a list of responses, each of these which are prefixed by self, so they can be used anywhere in the class. And now this makes the 2 test methods simpler because neither one has to make a survey instance or a response. And so the method test store single response here verifies that the first response in self.responses can be stored correctly. And so this verifies that all three responses in self.responses can be stored correctly as well. And so when we run this survey again, both tests will still pass. And these tests would be particularly useful when trying to expand your anonymous survey to handle multiple responses for each person. So now, after modifying the code to accept multiple responses, you could run these tests and make sure that you haven't affected the ability to store a single response or a series of individual responses. So remember now, when you're testing your own classes, the setup method can make your test methods much easier to write. You just make one set of instances and attributes in setup, and then use these in all of your test methods, just as you're seeing here when I'm calling my for loop. So let's go ahead and run this and see that we still get 2 tests being run. And there we are. You can now see that these have run 2 tests and it's all okay. So one thing to note now, when a test case is running, Python prints 1 character for each unit test as it is completed. And so a passing test prints a dot, a test that results in an error prints an E, and a test that results in a failed assertion prints an F. And this is why you'll see a different number of dots and characters on the first line of output when you run your test cases. And so if a test case takes a long time to run because it contains many unit tests, you can watch these results to get a sense of how many tests are passing. Amazing. We're now going over to our final challenge here. So go ahead and attempt this for yourself. Try your best. And again, if you need to recap anything that I've just mentioned here, go ahead and do that before pressing play, where we will then go through the solutions. Welcome back. I hope that program was useful. Let's now go ahead and dive into our chapter 10 solutions. Let's go ahead and close our testing.survey and let's begin. Right. So now, in this particular instance, we had to write a class called employee. And we had an init method which should take in the first name, the last name, salary, and store these as attributes. And then writing a method which adds 5,000 to the annual salary. So let's go ahead and do that now. I'm going to start off with class employee. We're then going to go ahead and write out a doc string and go for a class to represent an employee. We'll then go ahead and write out our init method. And we'll take self as well as our first name, so F name. Let's go for L name as well as our salary. We've now gone ahead and done that. Let's go ahead and initialize the employee. Let's go for self.first. And I'm going to simply do the same thing for last and for salary. So now that we've gone ahead and we've written that out, let's go ahead and give him a raise of 5,000 to his annual salary. So let's go for define, give raise. Let's choose self as well as an amount of £5,000. Again, our doc string to give the employee a raise. And then it's called self.salary. And let's add on the amount. Fantastic. So that's the first thing that we had to now do. The second thing, however, asks us to write a test case for employee and write 2 methods. One which is testing to give a default raise and one for a custom raise. And then finally use the setup method so you don't have to create an employee instance in each test method. So I've gone ahead and done that in chapter 10 solutions. Let's now go ahead and create a new file, and that's going to be within our challenge solutions here. And let's go for test_employee. Let's go ahead and import our unit test. We'll then say from chapter 10 solutions, import employee. We'll then go ahead and write out our class, which is going to be our test employee with our doc string. And then we'll go ahead and define our setup method. And within this, we'll take one parameter, which is self. We'll go ahead and write out our doc string here. I know it does become tedious at times, before finally initializing our employee. So again, let's go for self.rishi, and let's go for employee. Rishi is our first name, Bagger is our surname, and let's go for 65,000. Wonderful. We'll then now go ahead and write another method, one which is going to be our default raise, and one which is also going to be our custom raise. So now I've gone ahead and done that. Let's go ahead and initialize this. So let's go for our self.rishi, and let's give the raise. We're then going to call self.assert equal, and within this, let's go self.rishi.salary, and let's keep this to 70,000. And when we go to our final method, which is our custom raise, let's do the same, and we want to give our raise, and we're going to say 10,000. And then self.assert, and let's go for assert equal, and we'll go for self.rishi.salary, and let's go for 75,000. Beautiful. Now that is all done, we're going to finish off with an if statement, which is going to be outside of that method here. So let's go for if name equals our main here. Then let's do our unittest.main. Okay, so now that is done, let's go ahead and output this, and this should finally run 2 tests okay. And we can now see, hooray, it works. Ran 2 tests in 0 seconds, and okay. Brilliant. So that was the end of our programs there. That now brings us to the end of our session here. And I hope you find testing your programs useful and intuitive. So what do we learn in this chapter? Well, you learned to write tests for functions and classes using tools in the unit test module. We also learned to write a class that inherits from unittest.testCase, as you can see in this specific program. If we go ahead and open up our testing here, we can also see that we've gone through failing tests and how to work around your tests if they fail. And I remember that testing is an important topic that many beginners don't learn. And you don't have to write tests for all the simple projects that you try as a beginner. But as soon as you start to work on projects that involve significant development effort, then you should test the critical behaviors of your functions and classes. And that will in turn make you more confident that the new work on your project won't break the parts that do work. And this will also give you the freedom to make improvements to your code. So play around with tests to become familiar with the process of testing your code, and write tests for the most critical behaviors of your functions and classes. But don't aim to cover the full coverage in early projects unless you have a specific reason to do so. Thank you very much for being part of our journey here. This was the end of our part 1, where we've covered the entire syllabus of part 1. Please stay tuned for part 2, where we will be going through projects. And this is where you'll now be at a stage where you know enough about Python to start building interactive and meaningful projects. And this is where we'll be creating our own projects and how they will teach you to solidify your understanding and teach you new skills of the concepts that were introduced in this part 1 here. So what's going to be next? Well, part 2 contains 3 types of projects, and you can choose to do any or even all of these projects in whichever order you like. So before I finish off, let's go through those. The first one will be making a game in Python. The second one will be a data visualization project. And the third one will be a web application. So if you're looking to advance your skills in Python, then subscribe and like our page so you can be the first one to be notified when we upload those videos. If you have any other questions or any queries, feel free to contact us on the link below. Thank you very much.